Hello everyone, my name is Amit and welcome back to my channel. Today in this video, we are going to deep dive into the Git internals. This is the version control system which is powering millions of projects worldwide. If you have ever wondered how Git works under the hood, you are at the right place. So let's get started and understand how Git works internally. To understand Git internals, we have to understand its architecture. At its core, Git is a content-addressable file system. It has three major concepts. Number one is a working directory. This is managed by the user by having different files in it. There is a staging area. This is the temporary area managed by Git so that you can select all the files you want to put in the repository. And lastly, this is the repository. You can consider this as a data store. Consider this as a key value data store which is going to store all of your versions. Let's start diving into the working directory. I'm in a temporary directory now. I'm going to create a new directory. This is my working directory. So let's go into the working directory here and let's start creating our repository. To create a repository, we are going to use a command git init. So git init, this will initialize a repository. Now what it does behind the scene. Behind the scene, it creates a new directory .git inside your current directory. We call this as a repository. So if I look at this content, if I look at the contents of working directory, you can see a .git directory is created. If I go inside the .git directory, you can see there are multiple files and directories. So if I say ls, you can see there is a head, there is a config, the description. These are three files. There is a hooks, maybe info, objects and refs are the directories. We are going to deep dive into each one of them and we'll understand what exactly happens when you are creating the different versions of your files. Right now, I'm going to go back and create a simple file. So for example, I can say test.txt and I can add a simple file. Maybe I can say this is line 1. A very simple example here. Let's come out of it and I'm going to create a version of it. To create a version, I can say git status -s. This shows me this is untracked file. When you say question mark, that means this file is untracked. The repository does not have any idea about this file because we haven't committed anything yet. To commit something to the repository, let me go back to the diagram. To commit something from working directory into the repository, there is a temporary area called as the staging area. So you have to first add that file into the staging area. To add something to the staging area, we are having a command git add. So maybe I can come back here. I can use a git add. You can also use the file name, like in this particular case test.txt. But if you are having multiple files you want to check in the current directory, you can simply use the command git add dot. This will add your file which was present in the working directory into the staging area. And from staging area, if I want to put that into repository or if I want to create a version of it, I will use the command git commit. So let's use git commit -m. I can call this as my first version. That's it. Now I have committed my first version. So in short, if you are going from this to this, you have to take a pause in between this. This is kind of a stop in between. You have to add it to the staging area, and from staging area you can go to the repository. So that is generally called as a basic workflow. Now that you have understood the basic workflow, let us understand how Git works internally. Every file, every commit inside Git, it's stored in terms of objects, which are identified by SHA-1 hash objects. So let's create a new repository and let's dive into it. I will create a new repository here. Let's call this as maybe application 1, and let's go for that application 1 and let's start creating our repository. We saw earlier that to create a repository there is a command git init. Now this will create a new .git directory inside the same directory, inside the working directory. On the other terminal, I'm going to go inside that directory, so /application, and right inside this I'm going to go inside the git. There are many different files and directories. We'll try to explore each one of them individually. At the moment I'm going to go to the hooks. I don't need anything inside that for now, so I'm going to delete everything from that hooks. Yes, please. So right now if I go back, I can see how does that tree structure looks like. So under that .git, there is a file called as a head, there is a file called as a config, there is a file called as a description. We'll try to understand how that how those files are used later. Right now I'm looking for this objects directory because this is the most important directory inside the Git repository. As I was saying, like every file, every commit internally stored in terms of an object, that object will be created right inside this particular directory. So let's understand how does it work. To understand this, let me create a new file. Maybe again I'm going to use that test.txt file. I'll call this as this is line 1, a very simple example. Okay, now I want to understand how Git stores the version of it. To store this version, Git uses an object. So under the hood, Git uses 3 types of objects. One is called the blob objects, binary large objects or binary large file. The another one is something called as a tree object, and another one is something called as a commit object. So let's start one by one. When I add something to the staging area by using the command git add dot, if you see here, maybe I can use a command watchn. So it will kind of continuously run this command after every 1 second. It will keep on telling me what's currently happening when I fire a command on the left hand side. So when I say git add dot, you will notice an object will get created inside the objects directory. So if I go and say enter, you can see an object got created here under objects directory, which starts with 5e, and there are a few more characters here. So precisely an object got created with an ID as 5e1187c blah blah blah. What exactly it is? This is a hash, or you can call it as a SHA1 hash of the contents of that file. Can I do it myself? Yes, you can. You can use a git hash object command, and I don't want to save it. I just want to see like what does it give me back. And if you look at this command hash object, you can see it has created a hash of whatever contents you are having in that file. So this hash is used to create an object here. So the object name is exactly the SHA1 hash of the contents of that file. If you notice here, the first 2 characters are used to create a directory, and remaining characters are used to create the actual file. Now if I want to find out what exactly the file type here is, or what exactly the type of object here it is, I can use the command git cat file -t, and I can use this entire ID. Precisely, I don't have to use the entire ID. I can use only couple of characters, and still it will show me what kind of object I'm dealing with. So this object is called as a blob object. As I was saying, there are 3 types of objects. So whenever you add something to the staging area, behind the scene, Git creates a blob object for that file. So coming back here, I'm going to go for creating a diagram, and let's say this one here is a content. Probably if I look at the cat test.txt file, I can see this is the content. So whatever is there inside the file will get added inside this object. Consider this as my object. Okay. So this is nothing but my object, and this object stores kind of contents of your file. How do I verify this? To verify this, I can use the command, it's a git cat file. Instead of using -t, you can say -p. P stands for pretty printed. So I want to print the contents of that file, and if I look at this, it shows me exactly the same content I'm having inside my file. Wonderful. So this is the file. Okay, this is something called as an object. This object is called as a blob object. Let's say that this is an ID of that blob object. So you can see like how Git manages all of these objects behind the scene. Maybe I can use only couple of characters from here. Not all of them. I think this is more than sufficient. Okay, and probably if I look at the contents of it, this is how you can see. This is the line 1. This is the content of it. This is a blob object. Okay, so whenever you use the command, something called as a something like a add, you are going to see all the contents of that file will get added into an object, and this object will get stored under .git/objects/ whatever the name of the or whatever is the hash which was generated by looking at the contents of that file. Okay, now I want to create my first commit. To commit something, we can say git commit -m, and I can call this as my first version. Now let's understand what happens now. Last time when I added something to the staging area, it created a new object for me of type blob. Now I'm going to go for committing this changes So I'm going to say that enter the command git commit, and as you can see here, it has created two more files, two more objects. Out of them, one is called as a tree object and another one is called as a commit object. If you see here, it says that on your main branch you have a root commit which is having an ID 8DAA1EE. So if you look at this, first two characters are used for creating a directory 8D, and remaining characters are used for creating a file. Wonderful. If I want to see like what is the type of it, I can again use the command. Let's say git cat file -t. What is the type of this? This is called as a commit object. So let's go back here and try to grab this and say this is my commit object. Let's try to use a different color here and say this is my commit object. Now what is an ID of that commit object? Let me copy this here and say this is an ID of that commit object, which we can see right there, right? So if I look at this, this is the ID of that commit object. Now what's inside it? Let's go and try to find out what is inside that inside this file or inside this object. All of these are objects, right? So let us understand what's inside this object. You use the command again cat file, use -p, and this will show me the pre-printed information which is stored inside this particular object. It stores a tree object. So maybe I can come back here and say there is a tree, and like last time I'm going to use only a couple of characters here like this. This what you see here is a reference to the object which is of type tree. So this is the commit object which is storing a reference to the tree object. It also stores the author and the committer's information along with the date and timestamp. So this is Unix style timestamp on which this commit has been recorded. So maybe I can call this as an author info and then committer info. That's it, So both of them will get stored here, and along with this you can also see a message that you have used last time while committing it. So last one is the message. Now since it is a root object, you can see there is no parent stored here because the parent will be not specified for a root object, or you can call this as a commit object without a parent, which is why it is known as a root object. So this is my root object, as you can see here, and this root object is referencing a tree object. Now if you look at this ID ed681d, I think you can see ed is used for creating a directory and remaining characters are used for creating the file. I want to find what exactly the type of that object here is. So again git cat file -t and get this ID here ed68, and you can see that the type of this object here is tree. Now let's understand what's inside that tree object. So going back here using -p, and it shows that it has the mapping of blob files with the actual file names. Nowhere it is saying that the blob object it belongs to a certain file. It just creates a blob object which stores the contents of that file, right? Nowhere it is saying this is the test file, but it has to map it somewhere. So where it maps that blob object for that file name, it maps it inside the tree. So you can see here it starts with 100644. This is the representation of a file 100644. This is the representation of a file. So it seems like it is pointing to, let me use this one and say this is the different color, for example. So this is 100644. This is the code which will identify the entry is for a file, not for a directory. Okay. Next to it is the type of reference it is having right now. So maybe this is the blob, because the ID what you see here, it's like a long ID. I'm just going to pick up only a couple of this character here, and probably if you look at this one here, you can see that it ends with 8. If you see that this is nothing but the same ID here, which means this tree object is pointing to the blob object, and after this it also is telling you which file it is pointing it to. So this is like a test.txt. So test.txt. So what happens here in this particular case is, whenever you are committing some changes, behind the scene it is really creating those three objects. One is called as a commit object, the another one is called as a tree object, and another one here is the blob object. The blob object stores the contents of your file. The tree object stores the mapping of blob object and the file name, and the commit object stores the commit information. You can call this as a meta information, like who's the committer, when the commit has happened, or what is the tree object it is referencing to, so on and so forth. So precisely it is pointing to this, and this is referencing to that. This is how Git internally stores your content or internally creates a version of your file. Now, other than this, if you notice something, it has already created a kind of main file inside refs/heads. Now, what do you mean by this main? This is nothing but the branch. Now, in later part of this video, I'll talk about how the branching works. At the moment, I can see by default it creates a branch called as a main. In older version, it was a master. Nowadays, we call this as a main. Actually speaking, a branch is just a pointer to a commit. Now, if I look at the contents of this file, maybe I can say cat.git/refs/heads/main. You will see that this is nothing but the ID of my commit object. So this is my commit object, and this ID is representing that this is my last commit. Actually, this is my first commit, but this is the last commit, or you can call it as the latest commit. Wonderful. Along with this, it also has updated which is my current branch. So head is the one which is having the name of my current branch. So if I look at the contents of the head, something sort of that, you can see it is pointing to the current branch called as a main, which you can also see, by saying git status. So git status will tell you you are on the branch main. How Git knows you are on the branch main? It stores the name of the current branch inside the file called as a head. So head is inside the .git directory, and head points to the name of that branch, which is your current branch, which in my case is the main. So whatever happens henceforth will get recorded inside the main branch. Now let's create one more version of it, and let's see how or what exactly the changes you will see inside that commit object in the next version. So I'm going to modify that file by adding another line. Maybe this is line 2. A very simple change here. Again, I will create one more version by saying git add dot. If you notice it has created one more object here. Of course, the object ID is 9381EAA. That's what I can find it. I can use the command get file -p and use the command, use the address or use the name 9381EAA. So if I look at it, this is the contents of that file. So immediately, whenever you are adding something to the staging area, immediately it creates a blob object, which means if I look at this, it has created one more blob object here. What's inside it? I think these are the 2 lines which are there inside this particular blob. Okay. Now, what's an ID for that blob? Maybe I can just copy this here, and let's put it. The ID here is like 9381EAA. Yes, here it is. Okay, I've not committed anything yet. I've just added that to the staging area. So immediately it has created a new blob object for me. Now I'm going to commit this change by saying this is my second commit, for example. So the moment I do this, you will see 2 more objects got created. I mean, I can't see like which one of them is the commit and which one of them is the tree. So I'll have to look at this particular ID, and then I'll figure out this is my commit object. So if I look at git cat file -p, if you want to check like what is the type of it, you can use -t, and this will tell you that it is a commit object. So if I know this is the commit object, if I go back here and look at the contents of it, this is nothing but the commit object. So what I'm going to do here is I'm going to copy this and put it here and say this is my new commit object. What's an ID? Probably if I look at this one, this is my ID. So this is the ID. Now if you look at this, it is having a tree object here. So let's come back and say this is the tree object. Okay. It has the author information, commit information, the message, all of that. But if you notice, it is having a parent now. So now before the author, I'm having a parent. And who's the parent for this? The parent is nothing but the previous commit. So if you look at this, it's 8A, 8D-A1EE. If you look at this one, it is exactly the same what we have shown here. So probably if I look at this, I can say that it is pointing to my previous commit here. That's it. So whenever you are having a next commit, it's always going to point out to the previous commit by having a pointer called as a parent, right? Now it has got a new tree object. So this is going to be the new tree object, which is having an ID, which is recorded here. So if I look at that here, so precisely even before I look at the contents of it, I can say that for sure this must be the case, you know. So probably if I paste it here, and if I look at this entry, that means it is pointing to this tree is pointing to this object, right? If I look at the contents of it, this is the ID of that tree object. If I say git cat file, and if I put the ID of this, I can see that for sure 100644, that's the file's code. Blob is the type of object it is pointing to. 938 EAA, this is the ID of that object, the the blob object, and this is the name of the file. Okay, so this is now created, this already has created a new version here. So now we have got two versions created. So if I come back here and say git, it's going to be like git log one line graph color. If I look at this, you can see that there are two versions created. That's the first version and that's the second version. So as you can see here, whenever you are creating a new version, it's going to create three different types of objects. Per commit, it will create a commit object. Per directory, it will create a tree object, and per modified file, it is going to create a blob object. The blob object stores the contents of the file. The tree object stores the mapping of blob object and the file name, and the commit object stores the commit metadata. I mean, who has committed it, when it got committed, what was the message you have used at that time, and what is the tree object it is pointing to, and precisely if it is not a root object, which is the parent it is pointing to. Root object is the object which does not have any parent. So that's how we can identify that as a root object. And precisely root object will be always created at the very beginning. So that's a first commit. It's nothing but the root commit. Okay. Now let's do something interesting. You already have seen how Git manages all the versions by using objects. Let's create the objects by hand and commit again by hand. Let's see. So first thing first, I already have created an empty repository, created one file called as a test.txt. There is nothing right now. It's an empty repository. You can see on the right hand side, no object is created yet. I want to create my first object. Precisely when you add something to the staging area, it creates a new object for you, but I want to create it myself. So maybe I can say git hash object -w for writing the object precisely in that object directory for this file test.txt. So what essentially it does here is it gets the contents of that test.txt file and it creates a blob object. The name of that blob object is the SHA1 of hash of this particular file, and you can see that this is the SHA1 hash of this file. You can see here on the right hand side, it has created a directory with the first two letters, and remaining letters are used for creating the file. If I use the same command which I already have used the last time, you can see it is of type blob, and if I look at the -p, you can see that this is the contents of that file. Wonderful. Now that we are having an object, I want to create a tree, you know. So if you look at the diagram, you can see this is my blob object. Now I'll have to create a tree object. How do you do that? To do this, we have to use a command called as an update index --add cache info. We have to pass the actual entry which starts with something like 100644. You don't have to say blob. If you want, you can. Then there is a object ID, and then there is a name of that file. So it's like 100644. 644 is a 100644 is nothing but the call it as a way to understand it's a file, not a directory. This is an ID and then the name of that file, which in my case is test.txt. So precisely this will get added into its cache. Once it is there in the cache, I can use the command write a tree, and this will create a tree object for me. Watch on the right hand side. So right now I'm having an object which is of type blob. You saw that. By using the write tree command, it creates a new object. You can see it starts with ed blah blah blah, and this one here is my tree object. How do I know it? you can use the command again, git cat file, put the ID here, and you can see that it has exactly the same entry which you can see right here inside this particular diagram. You can also use -p in order to, -t in order to see the type of it. So if I look at -t, it shows that it's a tree object. Okay, so now we have got a blob object, we have got a tree object. Now I want to create a commit object. Now creating a commit object will require you to pass a message. So maybe I can say echo, maybe I can say this is my first commit, and then you can pipe it and say git commit tree. This is the commit tree. That means I'm going to go back and commit this tree which already has an entry for the blob file. Then this will create a commit object. Now this is my first commit, as you can see. So the moment I do this, commit tree, what it says, commit tree, the commit tree is the tree address. Sorry, I forgot to put the address here, or forgot to put the ID here. So this is an ID. So this would create a commit object. Could you see that? On the right hand side, it has created a new object which starts with the DC 3848 blah blah blah. This one here is the commit object. How do I know it? Again, you can check that by saying git cat file. Maybe I can say -t. It's the DC 3848. If you look at that, it's a commit object, and if you look at this -p, you can see that it's the same information which you can see right there, right? So see, this is how the git works internally. But precisely because this is the first commit, git does more than this, so this is not yet done, because if I look at the git log, it will say there is no commit yet. I mean, actually speaking, there is a commit, but it does not understand that because we don't have any main branch created yet. No problem, I can create a main branch easily, So if I know this is my commit object, this is the ID of that commit object, I can easily go back and create a new file. It's just a simple file. So vim.git, maybe I can go back to the heads and the main. Because main is my default branch name, I'm going to start with the DC. This is the name of my, this is the ID of my commit, all the ID, all the letters here. And this would create a new commit for me. You can see this is the commit. I have the main branch here. If I look at the .git head, it is pointing to main. So head is pointing to main is pointing to the last commit, this commit is pointing to the tree, this tree is pointing to the object. It fulfills the path. If I look at this, if I look at the git log, it will now record that yes, you have a one commit here. See? Now I don't need those commands like git add or git commit or something, So I can use these commands and get the same job done. Using the strategy what git does behind the scene. And there you have it, git internals. We have covered all basics, all foundations, and all building blocks of git. This is a very powerful tool, as you have seen, but at the same time, it's very simple at its core. It uses objects to store all the files, all the versions, all the commits. So, if you have enjoyed this video, please do not forget to like, subscribe, and share it with others who might find it useful. Until next time, happy coding. Thank you very much.